This is section 4.4, part 4 of 4. This is the last problem in this section. We've been solving word problems using linear systems. We just worked a problem where we talked about the distance. On this problem, our planes were going in opposite directions. On this problem, it's very similar, but where our cars are still going in opposite directions, but they're traveling towards each other, where this one was traveling away from each other. They work really the same way. We're still going to be using d equals rt, distance equals rate times time. So let's look at the problem. Kansas City and Denver are 600 miles apart. Two cars start from these cities traveling toward each other. They meet after 6 hours. Find the rate of each car if one travels 30 miles per hour slower than the other. So just like the previous problem, we know how far apart they are. It's just they start far apart instead of ending up far apart. We know how long they traveled. It's 6 hours. They start from the same time. And we know that one is slower than the other. The last problem was one was faster than the other, but it's the same difference. So we're going to start off by drawing a picture. If this is Denver and this is Kansas City, they're going to be traveling toward each other and they're going to meet somewhere. We want their total distance to be 600 miles. We know they travel 6 hours. We're asked to find the rate of each one. Okay, so let's say this one is going x miles per hour, and this one's going y miles per hour. Okay, we need to pick one of them to be faster. So let's say this one is the fast one, and this one is the slow one. We're not told which is which, so we could have chosen either way. And just like before, if we can find a way of talking about this distance and then this distance, we are going to be able to talk about we're going to be able to get our equations pretty easily. This distance is the rate times the time. X is our rate, 6 hours is the time, so this is 6x. Y miles per hour, this is our time, this is 6y. So our first equation would be 6x, this distance, plus 6y, which is this distance, and then it needs to equal our total distance. So that is 600. Okay? Now we're told one is faster than the other, or one's slower than the other. So if we take the fast one and subtract the slow one, we should get the difference, which is 30. The fast one we decided was x, subtract y, and we should get 30. This is the system we should solve. We need to get rid of one of our variables. Here we have ones on both of them, so they'd both be pretty easy, but this one has opposite signs, so I'm going to get rid of this one. If I multiply this second equation by a 6, I'll end up with a negative 6 here, and my y's will go away. So I'm recopying my first one. Multiply all the way through here, and you get 6x minus 6y is equal to 180. Add these together. The y's cancel out. 6x plus 6x is 12x. 600 plus 180 is 780. Divide both sides by a 12. And we get x is equal to 65. So one car is going 65 miles per hour. We're asked to find both, so take the 65 and back substitute. I'm going to plug into this one because it looks easier to me. So that would be 65 minus y is equal to 30, sorry. Move this over to here by subtracting 65 from both sides. And we get negative y is equal to negative 35. So y is going 35. So one car is going 65 miles per hour and the other car is really annoying and going 35 miles per hour. And that would be your answer. They're both reasonable. Cars can go that fast. If we got numbers saying they were going 200 miles per hour, I'd be really concerned. We could have fractions here. You could have decimals here, but we could not have negatives. So this makes sense.